Greetings! Welcome to my final presentation for Praise Summer of HPC 2016. My name is Jiri Blahos and the topic of my project was shallow water equations, more specifically parallelization of code and visualization of the output. Shallow water equations are three equations forming a mathematical model which can be used to simulate physical behavior of fluids in shallow areas like coastal waters or flows in the atmosphere, or they are also used to simulate tsunami waves in the ocean, because when you compare the depth of the ocean to its entire area, it's still considered shallow. So these equations have a wide range of usage in climate modeling. My first task for this project was to parallelize the existing code running the shallow water equations which I was given by the iCheck and which was written in Fortran. For the parallelization I decided to use OpenMP, and after some struggles and debugging I managed to parallelize it and test it on Theon, which is the Irish current fastest or biggest supercomputer. Here are some of the results I achieved using parallelization with OpenMP. You can see I was running the code on different sizes of grid and also using different number of cores, of course. And also I was comparing both Intel compiler and G-Fortran compiler, and you can see that obviously Intel compiler is a bit faster. And also I was experimenting with this heap arrays flag, which you use to tell the compiler if it should store the arrays on heap or stack, because when you use bigger grids and you use bigger arrays, you can't store them on stack anymore, and you have to tell the compiler to store them on heap, otherwise you get segmentation faults. But now let's move to the more interesting part of my project, which was visualization, of course. I used ParaView first to produce some 3D water surface images based on the output of the model. So you can see something like this, which basically is just a small drop at the edge of the domain, which then forms these waves bouncing off the borders, because boundary conditions here are called reflective, so everything that comes to the border is reflected back. Another type of boundary conditions you can have in shallow water equations is reentrant boundary conditions, which might sound a bit weird, but basically it's a condition where everything that comes out at one side comes in back from the other side. So basically it means that there are no boundaries and the whole surface is like a sphere, because the edges are actually connected. As the next step, I was trying to make the visualization output look more nicer and appealing to the viewer. So I was experimenting with colors, and I added some transparency to the water surface as well to make it look more realistic, and also added some background just to make the whole image look nicer. After making the ParaView visualization, I decided to experiment with something else, and I actually wrote my own OpenGL application to render the water surface from the model output, so I could experiment with some more graphic effects. So this is what I ended up with. On this simulation you can also see the difference when using viscosity, which basically is a friction within the water itself, and you can see as the water waves slowly fade out and the water surface becomes flat after a few seconds again. And that's it. That's what I was doing during those 2 months in Dublin. It was a really good experience and I learned a lot. So thank you for your attention and goodbye.